Hello everyone! In this video, we will present the main improvements in the 2024 version of STRAP. In the Stages menu, the Multi-Storey Stage option has been added. This option allows to define construction stages. Let's check the option to activate the multi-story stage and click on Edit. The program will automatically identify and display all the levels in the model. You can delete and add levels. The program creates stages according to the table, and the loads that will be defined later can be applied to each stage separately. In the results, the software will combine the results from all the stages. In this example, we can see that the program has identified 5 levels, and therefore the program will generate 5 construction stages. We'll switch to Render View to demonstrate the model's structural scheme. You can see a column that's supported on the beam. Let's go to the Loads tab. Here, we'll display the defined loads. You can see that 2 loads were defined. The loads are identical. The first load was defined as applied on the whole structure at once, and we'll define the second load as applied on the multi-story stage according to the construction stages. Here's a sketch that illustrates what happens internally in the program for load number 2. You can see that the program internally generates 5 stages and applies the load on the top level of each stage. Let's solve the model. In the results, we will display moments in the beams and focus on the beam that supports the column. You can see that the moment for the first load is 486 kilonewton meters. For the second load, the moment increased to 582 kilonewton meters. Let's look at the displacement at the top of the column. You can see that for the first load, the displacement is 3.64 millimeters, and for the second load, it's 0.89 millimeters. This example illustrates the difference in results between a structure loaded at once and a structure loaded in stages. A new creep calculation option has been added to the software. We will demonstrate the new feature on the previous model. In the same menu where you define the multi-story stage, you can define the casting day of each stage. The menu has an option to define the number of days between each stage's casting day, or to define the casting day of each stage. Let's go to the Loads tab. On the menu on the right, we can see the new option, Creep. Clicking on this option will open a menu where we can choose the defined loads for which we want to include creep in the calculation. We'll choose load number 3 and check the Add Creep box. Under T-Start, you should input the number of days after casting when load starts. Under T-Creep, input the number of days for which we want to calculate the creep. Inputting 0 or leaving the cell blank will be equivalent to calculating after 70 years. And finally, input the humidity percentage. You can select the code according to which the calculation will be performed. In the Materials option, you can define the concrete strength and the type of cement. In the Reinforcement option, you can define the reinforcement percentage in the element which affects the creep calculation. Let's solve the model. In the results, we can see the creep factors that were calculated by the program. Click on Display Table, and then check the Creep Factors option. In the table, we can see the creep factor for each element based on its casting time and based on the time loads start in each stage. For example, for the column on the first story, 10 days after its casting, the program calculated a creep factor of 1.6. After 24 days, the load was applied on the story above, and the creep factor is 1.35. When the load is applied on the 5th story, the age of the concrete is 66 days. And therefore the creep factor is 1.11. Now let's display the results. Let's look at the displacement at the top of the column. We can see that when creep was considered in the calculation, the displacement increased from 0.89 mm to 4.25 mm. Let's check the moment in the beam that supports the column. For the model where the load was applied at once, the moment is 486. For the model where the load was applied considering the construction stages, the moment is 582. And for the same model, when considering creep, the moment is 535. It should be noted that the effects of creep cause an increase in displacement and a redistribution of loads without an increase in the total loads. The model list view has been redesigned. The model's preview appears on the right part of the screen. The model's status icons have been redesigned. A model containing only geometry, a model containing loads, and a model containing results. New icons have been added to the toolbar for zipping and unzipping models. In the results, a new option has been added to export reactions to files. The reactions file can be defined as a load in any model. Let's look at the following example. In this model, we see the reactions of results combination 1 out of 6. In the menu bar, under Output, choose the new option, Export Reactions to File. In this option, you can choose to create a reactions file for a load case from the list, for a results combination from the list, or for an envelope of results. You may also create files for multiple loads, or multiple combinations of results. After choosing one of the options and clicking on Continue, we'll select a node in the model. The node is used to determine the reactions level and as a reference node. After selecting the node, we'll name the file. The file name extension is SRE. Finally, we'll click on Save. In a model, in the Loads tab, let's define a new load. We'll name the load. On the menu on the right, we'll choose the Global Loads option and click on Define. In the window, we'll choose the Reactions File option. You can define a factor for increasing or decreasing the loads. You may choose how to apply the load, as a load on nodes, beams, or elements. After clicking on OK, we can select the reactions file we previously saved. The software will give the option to ignore reactions in certain directions where you do not wish to apply the load. In this example, we'll apply the loads only from reactions in the X3 direction. After clicking on OK, you can use the pointer to select the load location or select the option on the menu on the right by Nodes and choose a node where you'll place a reference node that was previously selected when creating the reactions file. We will select the node in the corner of the wall. You can see that concentrated loads were created from the reactions in the X3 direction. We now have the option to hide the element mesh from the display and only show the element's contour. This new option appears under Display, Remove Element Contours, and there is also an icon in the top toolbar. This display option gives the model a cleaner look. Under the Restraints display icon, you now have the option to change the restraint symbol size. Render View now has the following new features. The type of restraint is graphically displayed. Here are examples of a fixed restraint, a pinned restraint, pinned and restrained for rotation about X3, restrained in X2 direction only, and a spring. The restraint size can be defined in the render parameters. Local axes can now be displayed. When the model display is limited between levels of coordinates, the display will slice elements in the exact coordinates location. For example, let's limit the display to a coordinate located 1.5 meters above the selected node. And you can see the program sliced the elements exactly in the coordinate we chose. When the display is limited to a plane, such as this slab, the display distance above and below the plane can be defined in the render parameters. Using this option can clearly show elements supporting the slab and elements supported on the slab. Some actions can now be done in render view. For example, let's remove some beams from the display. When we place the pointer over the element, it changes color, and when we select it, it changes to another color. In this example, we selected two columns, and both were removed from the display. An icon has been added to the toolbar that allows loading a DXF file and changing the parameters of the drawing displayed in the background. When working on a grid model, you can now rotate the model by holding down the Control button and clicking and dragging the left mouse button. The local axes display has been improved, and below the icon, an arrow has been added to allow making changes in the local axes parameters. For example, displaying local axes only of beams or elements and in selected directions. When performing checks in the geometry, it's now possible to locate unconnected intermediate nodes on beams. In this example, you can see that beam 354 is not connected to node 263, which is located on the beam. When we show the numbers of beams and nodes, we can see that node 263 is not connected to beam 354. Performing the split command under beams solves the issue. For the following types of slabs: slab with rounded voids, slab with rectangular voids, closed waffle slab, you now have the option to ignore stiffness in the weak direction. When calculating punching, there is now the option to subtract from the punching force the load applied on the critical contour area. In this example, we see the effective force that's applied without the subtraction. After we go to Defaults and check the new option, we can see that the punching force in perimeter U0 remains the same, and the punching force in perimeter U1 decreased. In the Draw Beam option, it's now possible to define a beam as a cantilever. Let's look at the following example. If we do not define the beam as a cantilever, we receive the deflection of the beam in relation to its end nodes. And if we do define the beam as a cantilever, we receive the displacement of the cantilever relative to the supporting side. In the S-Table module, used for managing beam sections, you can transfer sections between different libraries. This feature gives the option to transfer and use cold form sections that were created by other users. Let's demonstrate how to add to the Sections library some cold form sections we wish to use. In the menu bar, select File, Retrieve Sections from File, Other Table. Select the file that contains the sections you wish to copy. You will then see the list of sections in the file. Select the sections you wish to copy and click on OK. We can now see the sections we added to our sections library. In the Weight Definition module, it is now possible to display weights per story. These circles show the mass centroid location for each story, and to the side of the model, we see the weight of each story. You can also display the weight alongside the rotational weight. Thank you for watching.